So this will be a short one, but it'll be fun. You remember what we were talking about with these lists, immutable lists that can share tails, right? Um,
Hmm.
and I just bring back that. Oh boy. Okay. Oh right, that's great. Oh, that's what this needs. This needs I just had a thought for an improvement for this book software here. We need forward and back buttons. We don't have forward and back button. Oh, we do at the bottom, but we need them up here. Anyway, whatever. Um, this is how these lists can work, and you prepend by just creating a new list, and you get the tail by just looking at the tail. So I could take the tail of list one, and that would be the same as list two. I could take the tail of list two, and that would just be C and D. That makes sense. Are you following
Hmm.
that? Okay. Okay. And then I think we wrote one of these methods. We wrote whichever the first one was. Prepend, yeah. So this was just,
Yes.
the next is cloning self.head, which is just a shallow copy. It's just incrementing the reference count. And then the element is just the new element. And then all of this is boilerplate, right? It's just we need some because it's an option. We need a new RC. And of course, it's a node. And this is our new
Hmm.
list. So that's all clear. Something I wanted to make clear is this we have to do with self.head.clone, so it kind of looks like we're actually cloning it. I said this last time, but importantly, the reason why this increments the reference count is because this is actually option.clone, right? Because self.head is an option. But
Hmm.
it's an option of an RC. It's an option of an RC, right? So the implementation of clone for option, if I can actually go to definition, wow, that was slow,
Hmm.
uh, is that if it's none, it's just none. But if it's sum of cloning the inside. So this line, this little bit, is actually the thing that clones the RC. So RC
Hmm.
implements clone, and when you call dot clone on an RC, you you just increment the reference count, right? So it's important though because this is how it can be sneaky. Normally, clone is a deep clone, but if there's ever an RC in there, and sometimes it's hidden in there, inside a generic, right? If there's ever an RC in there, then the call to clone actually shallow clones the thing inside the RC. It shallow copies the thing inside the RC. It calls clone on the RC, which means it makes a new RC to the same place. Um, this doesn't matter yet, right? You might be wondering why do you care? Because the thing behind the RC is immutable, so it's fine to share it, right? Does that make sense? I mean, this is a general beautiful thing. Works for file systems, works for memory management in the operating system, works for Rust as well, any language. But a good thing to know is like if you're on the same computer and you want two things to have access to the same data, if they never change that data, then they can have the same copy. They can share a copy. If one of them changes it, they might need their own copy. But if they never change it, and we can have a shared copy. So this importantly, that means that the whole difference between shallow copy and deep copy doesn't matter if you can't change it. Doesn't matter if it's immutable. Okay. So in this case, this is totally fine, and our list is not compromised at all because we can't change the thing inside the RC. And RCs by default, you can't change the thing inside them. But in just a little bit, we'll see more about that. But first, we have to we'll see how that isn't always true. But first, we have to write tail. Okay, pub fun tail. Good. My latency isn't so bad. Again, takes immutable reference to self, because everything with this type does, because nothing changes. And we just need to take. We don't need to take any parameter here. We're just saying, give me the tail of this current list. So we need to do self.head, and because head is an option, we're going to map. So that the tail, no, okay. What we want to do is we want to return a list. Okay, let's think about that first. we're going to return a list, or I guess I could have said self, but whatever. We're going to return a list whose head is somehow derived from self.head, right? That's really all a list is. Okay, so self.head.map. And I'm doing this .map because, here we knew that we were going to end up with a head, so we wrote sum, and we were creating a new head, right? Here we're not creating a new head. Here we're extracting the next head. So I'm going to call this n for node. She probably has a better word for it, but n, and then what type is n? It's an RC of a node. Okay, so I need to do n dot next. What's going on here? Expected option of RC of node found option of RC of node. Right, because n dot next is n dot next is an option, and the thing we pass to map returns the thing that will go inside the option. So n dot next is an option, and then we put another option around it. So what we need to do is we need to make it so that if either of these options are none, right? If the outer option is none, that means our head was already none. So then, do you see what I mean by we have two options? We have an option inside an option? Or did I lose you there?
Yeah.
You see that,
No,
right?
I got
Okay.
you.
Yeah,
So
yeah.
it's just like object wrapping.
Yeah. One inside the other. Russian nesting dolls, or Ukrainian nesting dolls, or whatever. Nesting dolls. And yeah, so we have an option of an option. So we need to flatten this. I don't know how she does it, but I know how I want to do it. I think there's a method called flatten that will literally take this. It's defined on option of something, I think. Maybe I'm totally wrong. It'll literally take this, and then it'll say if either of these are none, the whole thing's none. But if both of them are sum, then we end up with just one option that is sum. So it takes this whole type, and it'll return this type, and it follows very natural logic. If it can't find an actual RC of node, then it ends up being none. But if it can, then it ends up being sum. Does that make sense? So let's see if this method actually exists. It's called flatten, not flatten I. Does that exist? No. What is going on here? Option of option. Why is that not working? What is happening? Okay, now I have a different error. Cannot move out of an RC. Okay, right? Again, same question as before. Maybe you remember this, maybe you don't, but I spent all that time saying we can share RCs, we can duplicate them freely, just like shared references. But then I had this cannot move out of an RC. Do you remember why, or do you remember what we need to do to fix this? Because we can share RCs, we're just not doing it yet.
What do I see? Not really, honestly.
Okay, so let me see if I can bring back the diagram that I had. Oh my god. Look at this search bar. Look at how long it's taking. I have no idea what's going on with my computer.
Okay, so moving out of RC, no, object. Okay.
So down here, we have a really simple example, right? We have two RCs to the same node. Do you see this?
Give me a second.
Yeah, maybe my screen latency is really bad. I don't know.
Okay, I see it now. Yeah.
Okay, yeah. So moving out of an RC happens. Let's go back to that. Let's say okay. So this makes sense, right? We have an RC, we've only got one RC to this place, right? Where did the move out of the RC happen? Well, it happened when inside this node we were trying to access the next, right? So in order to do that,
Mm.
actually, okay, unfortunately it's a little complicated here. This node is actually two things. You know what? Bear with me because I'm going to stop using freeform because I kind of hate it. I'm going to use Excalidraw. Um, and I can even share this with you so that maybe you can, I don't know if that'll just be confusing, but you could look at it, I don't know, in your free time. Um, but of course it takes a while. Oh my God, unformatted Times New Roman text. Okay, here we go, here we go. Does it work? Kind of. Oh boy. Okay, no. Okay, so I have one of those. And then, no. I have, oh God. Okay, it's like the Vim of diagramming tools. Because it's got all these keyboard shortcuts. You see these little numbers here? Like I can summon. Oh, maybe my screen is probably too blurry to do that. I'll fix that later for the next one. But we have reference count 1. Make that wider so it all fits. And then wow, it's laggy. I really hope my computer decides to cooperate. But the point is, I have a node, or I want to do it like this. I want to do text up here that says node, and then inside the node we have, keep clicking too many times, we have L and then too few. Now I will learn this tool better. I'm sorry. Okay, elem, right? Inside the node we have an element. And then we, importantly, this guy, he points over here. Okay. And what else do we have inside the node? You can look at this if it helps. What else do we have inside the node?
Okay, firstly, give me a second
Yeah.
so for picture to
Oh,
synchronize.
I'm sorry. Yeah.
Okay.
I don't know what's going on. Maybe my connection. Maybe my computer.
I bet it's a connection issue.
It's both at this point, but who knows?
Okay.
Do you see my editor now?
Yes, yeah.
Okay. So
Not
other
only
than
we
the
have the
element,
element itself,
we
yeah,
have the
and
element,
an
and
option.
then this next. Yeah. So I'm gonna, and it is an option. It's an option of an RC. So I'm gonna call this uh next. No. Uh and inside it we have an, let's say we have, an option. I promise this is necessary. Well, inside it we have an RC, right? We have another RC of node of t. Because let's say that this actually is not alone. So now we have another arrow pointing somewhere. We have at least 2 items in this list. And then we have this whole thing again, which I will select somehow, like this. But let's say here we have none. Okay, so actually this was some of this thing, right? Okay. Are you following so far? Is the video
Mm-hmm.
synced up enough?
So,
Okay. Let me actually, yeah, this will be better. Let me just
okay.
share. I'll just put this link in the Discord for now. No, not that one. And here and okay. Do you see that? I sent it in the
Okay, one sec. I
hash
see the
rest
link.
reading group chat. Yeah. Oh, okay. I see
Yep.
your yeah. Cool. Okay. So now maybe you'll see things faster in Excalidraw than on my screen. I don't know. Maybe it's about the same. Whatever. Okay. So what's the point of all this? We want the tail of this list, right? This is the head.
Mm-hmm.
Um, can you see which one I've selected on your Excalidraw?
Yeah. So.
Okay, cool. Yeah. We can see the tail. We want the tail of this. So we want a new RC, and we want it to point here, right? We want our new
Mm-hmm.
head to point here. Okay, so that makes sense. What do we have to do to get this to happen? What's the thing that we didn't do here that we needed to do? Because it looks like we did it fine here, but there's a problem.
Uh, would we need to unpack this option first,
We
or
would.
is it alright if we?
Let's not worry about the code that we're writing. Let's worry about what else do we need to update in this graph. Because, yeah, we have to look at this and we're like,
Yeah.
some, and then,
So
yeah, this reference count, right? Okay. So what do we
mhm.
need to do to it? We need to,
Most probably increment it.
yeah, definitely. Okay. So this is why we're having the can't take out of RC, can't move out of RC. Because by default, no, I'll go back to this. Because there some types in Rust are clone, that is, they can be cloned, and a subset of those types can be copied. Do you remember what the difference between clone and copy was?
Yeah. So practically a shallow and a deep copy, right?
Eh,
Uh, uh,
kind of. Kind of. It's a much more programming language level semantics, though. Shallow and deep copy mean things to humans, right? The
mhm.
rules are that copy just copies the bits of the thing that you're copying. Clone can do other stuff, though. So often we need clone to do deep copies, but here we actually need clone to do a shallow copy, right? We're doing a shallow copy. We're not making a new copy of the
Hmm.
node, but we need clone because we need to do this. And RC cannot implement copy if when you copy it, it increments something. It doesn't work. Rust requires that a copy just be like this control C, control V. That's all I can do if the type
Hmm.
implements copy. But if the type implements clone, then I can do whatever the hell I want, like increment the reference. Okay.
And
So, do you have an
oh,
idea of how to fix this?
and why the error is move out of
Yeah.
RC?
Sorry, what? Right. Oh, move out.
Why
Okay.
the arrow says, yeah, so.
Right. This is tricky, but it is because what we're trying to do is we're trying to take this. Okay, I'm not sure about all the antecedents, like which RC the problem, but it says something. Okay, move occurs because value has type std option of RC. So this is talking about an option. So that means it must be talking about n.next, not n, because n at this point is just a RC, right? So n.next is an option of an RC which does not implement the copy trait. So we can't just copy n.next. So that means because we didn't write .clone, n.next is going to get moved out of n. N is the RC in this case. What it means
Mm,
to be moved out of something is we're invalidating the old copy because this thing is not copy. This thing does not implement copy. N.next does not implement copy. So we can't just copy it and leave both around. And all Rust is ever going to do when we don't call clone, when we just ask for the value like here, all Rust is going to do is copy the bits. The difference, or no, it's either going to copy the bits, just copy the bits like it would with an integer or a shared reference, or it's going to copy the bits and invalidate the old one. And the
mhm.
reason why it does it like marks the old one as you can't use it anymore. And that's called a move. A move is where you just copy the bits, but then you say you can't use the old one, right? And the reason why we have to do
Mhm.
that is because this thing doesn't implement copy, which makes sense because RC doesn't implement copy. So n.next doesn't implement copy because RC doesn't implement copy. And we're trying to
Mhm.
move out of it, or we're trying to move it because we didn't call .clone and it doesn't implement copy. And what does it mean, cannot move out of an RC? Well, this means we can't move out of n. And the reason is that in order to move out of n, which would mean next is part of n, right? N.next is part of n. In order to move out of it, we're trying to move out of it, and we'd have to mark the old version as invalid, right? Because that's what a move is. And we can't do that because it's behind an RC, and you can't mutate through an RC. You can't, so we can't mutate the old
Okay.
thing. Now, actually, even trickier than that, even if RC somehow gave us the ability to mutate something, but it didn't give us ownership. If RC was like an ampermute, instead of like take this example, but it's ampermute instead of RC, right? We still can't move out of it because moving out of it means we mark
Mhm.
the old thing as invalid, which is harder to do. Like we can't do that even if we can modify it. If you have an ampermute, you can replace it with whatever you want, but you can't just invalidate it because later someone else might look at it.
Okay. Yeah. So,
Yeah. No one else
yeah.
is looking
Okay.
at it now because it's ampermute and we have exclusive ownership, but later someone else might look at it. So the only things that we can move out of are things that we actually own. We don't own the thing inside this RC. We don't fully own it. We shared own it, which means we can't modify it and we can't move out of it. Okay. Do you follow? That was really long, but yeah, you follow. Okay.
Yeah. Yeah.
So what do you think you need to do to fix this method?
Well, one of the obvious ways, if I
Hmm.
picked up it correctly, then
Yeah.
is just implement the copy.
So we can't implement
Well,
copy.
what?
We can't implement copy
Yeah.
because you can't. We need to do something more to RC. Sorry, RC needs to do more things when you copy it. RC implements clone though.
Mhm.
We just need to call a method. We don't need to implement anything else.
Oh, okay.
Yeah.
So if mm, but if we clone the RC, does the even if we have, let's say, 500 clones of the same object, does
Yeah.
it does not affect the reference count at all?
No, no. Cloning will affect the reference count.
Okay,
Cloning affects the
yes.
reference
Okay.
count correctly, but the whole point of this, I didn't make this explicit enough, I guess, and it was no, I didn't. It's tricky, so I'll say it again. When you clone an RC, you do increment the reference count, but the reason why we have to
Mhm.
call clone, why it can't just be copy, is because incrementing the reference count is doing more than just copying the value. Okay,
Yeah.
yeah, yeah. So I feel like you're understanding it. Maybe it helps to look here. Is there anything we do here that we don't do here?
Mm,
And then if you don't get it, then I will run the compiler and it may tell us how to fix it. If not, I actually don't remember.
1 second. Let's see.
Yeah.
If we Okay, so if we run a clone of a head, which would be an option, right? No, not an option.
A clone of a head would be an option. Yeah, because head is an option. The clone never changes the type. Clone always gives you the thing of the same
Right.
type.
Hmm.
Okay, so you're saying we should try cloning
Oh,
this? Or,
I'm not sure because
okay.
even uh, if we clone the option itself, then obviously, well, not obviously, but I assume it's not going to affect the reference count. But then
No, it
uh,
does.
I'm not
No,
sure
no,
whether
no.
or not
Let's look
it
at this.
does.
Let's look at let's go to so here we were cloning an option. We were cloning self.head, right?
Hmm.
Um and let's go to this definition. Clone on an option calls clone on the inside. And here the thing inside is an RC. So this will clone the RC, which will increment the reference count.
Okay.
So just tell me where to write clone. I'll give you that. It's just writing clone. That's all we have to do.
Okay.
Yeah.
Okay. Let's go with head.clone.
Okay. I thought about that for a bit and I thought that was right. Okay, so let's see. First, let's imagine what we're doing here. What you just said is, or actually, do you want to see like what do you think head.clone does? I don't want to show the compiler error yet. Let's see this and then we'll see. So this is the
Okay.
head, right?
Mhm.
And sorry, let me fix up this
Okay.
reference count because it shouldn't be 2 right now. It's 1.
All right. So in my mind,
Yeah.
practically speaking, we would have a copy of this
Mm-hmm.
reference code. So it's as if
Yeah.
like
And then
this.
what's the
Oh,
other
then
thing that
it's
clone
gonna,
does? Clone does one more
yeah,
thing, right?
it's gonna point, right.
Yeah. And yeah, okay. Is that what
So
we
would
want to
it be
do?
something like that? Yeah.
Is that what we want to do?
I assume we. I assume we don't.
What do we
What
want to do?
else?
And you don't have to draw out what to do exactly, but let's just imagine, how do we want our new list? We want it to be the tail of the old list. So which node is our
Right.
new list going to
So
start with?
to to boom.
Right.
We want to have a pointer to the next node, right?
Yeah, and just update the reference counts. Okay. So which reference count did you increase there?
Of a next node, right?
Okay. So that means we have to clone something that includes this an RC to this, right? We have to clone the RC to this in the end. So that means we have to clone next. Does that make sense?
But next is an option. Yes. Yeah.
Yes. And
But
cloning an
next.
option clones the inside. So cloning the option causes the RC to be cloned. It's if I go to the definition of option.clone, right?
Right. Which
Option.clone, if it's
the thing we
some
don't want to have. So
no, we
yeah.
want to clone the RC. We this X
Right.
will be the RC. So when we clone the RC, it duplicates the it not duplicates, it increments the reference count. What's important here is exactly the tricky thing that I also stumble on. When you clone the option, it does whatever the clone of the thing inside the option is. So in this case, it just increments the reference count. So
Mm-hmm.
even though I'm saying it clones the thing inside the option, it's still a shallow copy because it only shallowly copies the RC, right? It just it just
Mm-hmm.
duplicates the pointer and increments the reference count. Are you following, or you know? This is basically where I want to
Oh,
stop
okay.
anyway. So
Yeah.
yeah,
So
yeah. Okay, so what do you want to do to this code? This clone didn't work. Let's look at the error here. It might be interesting. It said consider cloning the value if the um. Oh, it's confusing. I don't know what that error was, but this didn't help, right? We still have cannot move out of an RC. That's confusing
mhm.
because we did clone an RC, but we cloned the wrong RC. Now we have our own head, and now we're trying to move out of that head. We have our own pointer to the head, but now we're still trying to move out of it. Here we're still trying to so what we need to do is where it said cannot move, we needed to clone. Does that make sense? Let me just show the
Mhm.
cargo build. Let's see exactly what happens here. Oh, that's awful. That's hilarious. Okay, so one, it's writing some crazy code that no one would ever write because it's crazy verbose, but it's saying this is what. So it's actually advising that we do what your thought was for some reason. It is advising that we do this. It's writing it differently. It's saying, write all this bullshit. But I can promise you that what this does is it calls clone on self.head. Um, I don't know why, but it's very wrong. It's like, consider cloning the value if the performance cost is acceptable. One, this is the bad side of Rust in my view. You get the good and the bad. The bad side of Rust is these compiler messages are great, but this one in particular I think is absurd because um it's not just the like one, it's like consider making your code slower. Like that's how it sounds to me, right? If the performance cost is acceptable. But one, this is necessary to make my code work. And also, in this case, all I'm doing is adding an increment. Like it's not, it is cloning, but it's not that expensive. So it's just weird. But anyway, more importantly, it's wrong about where we have to clone. We have to clone here. And now, so the problem was moving out of n.next, right? And that's because we were just doing n.next. Now we're not moving out of n.next at all. We're calling clone on n.next, and clone takes a reference to self. So that doesn't take n.next. And we get a new thing. This new thing, this clone of n.next, is something we own. So we're not taking out of anything anymore. And now, once everything updates, we have a weirdness, but it works. It's still, let's restart the language server, because my tooltips are out of date. But it's thinking about it. If I do cargo build, what? Wait, maybe we still have a problem. Oh, we had two problems. Do we have to do this? I hate that. No. I'm just rebooting Zed because Zed is being incredibly slow for some reason. Oh my god. I gotta get my computer checked out. Or something. Or I gotta reinstall Mac OS or something, because this sucks. This is not right. Let's look at the book again. Oh! So we did have to do something with self.head. But we don't want to clone it, because if we clone it, we're not, like, in the end, we're not putting this clone anywhere. The way you want to think about RCs is that you clone them when you're handing off the shared ownership of something to some other place, right? And we do want to hand off the ownership of the tail. So this clone makes sense. We want to hand off the ownership of the tail because we want a new list with the same tail as us. So we need to clone our tail. We need to clone our next. And by hand off, I mean after this method finishes, we're done with. After this method finishes, after this method finishes, we're not done with n.next. We need a clone of it because it needs to stick around, right? It needs to stick around in this new place. But we don't need to clone self.head because this clone of self.head is just a temporary value. If we run this, this gets created and then we map on it and then it disappears because we didn't actually save self.head.clone anywhere. We saved self.head.clone.map and all this bullshit .flatten somewhere, right? So that's sort of the intuition behind why we don't want to do this. My editor is still happy, but I think cargo build is still unhappy. Let's see. Or maybe it's happy and that's its own lesson. I can't decide. No, it's fine. Okay. It's fine for us to clone it, but it's completely unnecessary. What we're doing here is we're creating a clone of the head. What we're doing here is a bunch of bullshit, but I can show it in Excalidraw. What we're doing here is we're doing like what? I hate Excalidraw. Excalidraw is just bugging, but it's just very slow. Okay, we clone this, right? So that means in order to be totally finished with cloning this, we need to, also point there, and then we need to increment the reference count, right? Actually, can you increment the reference count? Because I can't make my computer work. Thank you. Okay. And then, because this is sum, in the map here, we end up cloning this thing, right? We end up cloning n.next. So can you clone
Hmm.
n.next? Well, actually, no, we've already done that because we already created this, right? This is a clone of this guy, or of the
Hmm.
inside of this guy. Okay, so now we have that. And now this has a reference count of 2. But then we never stored this RC anywhere. So what happens at the end of this method? Well, just before this
Oh,
returns, it drops. So this goes away. And then you can delete the arrow and also decrement this reference count. So we didn't need to do that thing with this reference count at all. Do you see what I mean?
yeah.
Yeah. So instead, what we're supposed to do, but it still compiles, it works. But instead, what we want is the problem here is that self.head has a type of like this is going to bug. This is going to be a compiler error because self.head is an option of an RC. And we're trying to move that, like map wants to take ownership of the thing inside the option. If my editor will cooperate and be fast enough, which it will not, we would see that map takes self. Like an option of an integer, you can map on it and it'll duplicate stuff, it'll copy stuff, but that's because an integer implements copy. An map wants to own the like the thing inside the option. And that's good because that way we end up with n being an RC, right? Uh,
Hmm.
we want we want the thing inside the option directly. We don't want a reference to it. We want the thing itself. Shut up. Okay. So instead, what we want is an option, no, I said all that. Normally, we want the thing itself. But in this case, all we want to do is we want to clone its next. So we just want a reference to self.head. So what we actually want to do is we want to turn this option into an option of a reference with .asref, which is what we do here. Self.head.asref, she just does this all intuitively. So I'm glad I did it myself, so we made different mistakes. Self.head.asref takes self.head, which is an option of an RC, and turns it into an option of a reference to an RC. So then when we call map, in here, we get a reference to an RC. And that's fine because then all we want to do is access the next thing. So this dot actually dereferences that amper RC twice. It turns it into, look at the node. Look at the node inside and look at its next, which is fine. All we want to do is look at it. And then we clone that thing, that node, no, not the node. We clone this next, which is an option of an RC. We clone that. And then, this was just a shared reference. So there was no reference count associated with it. It was just I'm borrowing it and it's statically proven to live long enough. And it's statically proven because we just have an immutable reference to self, which means self will stick around and self.head will stick around. So we don't need the reference count, right? That extra reference count was silly for head because we know that head is going to
Hmm.
stay around. And that's where I want to leave you. I didn't actually quite get as far as I wanted, but I promise we will see how it matters that this is a shallow copy in the next meeting.